Welcome back. Today we're going to talk about trig ratios. And trig ratios is one of my favorite topics because to me it's just logical sense. It's lining everything up so that it fits and we get our ratios correct and we can solve right triangles. And there's tons of applications that go with it. So the first part of this is going to be a quick review because this is a pre-calculus class. So as you do this, you should reminisce back to geometry, maybe even algebra for these basic parts, and then Algebra 2 or Algebra 2 trig, whatever you've taken. So these first parts are going to be something there that are going to be review, and then we're going to move into some more of the application stuff later as we get into this video. So here we go. What does Sohcahtoa stand for? This is a review. If I'm looking at this right triangle, and this is marked over here, so this is our 90 degrees, we're talking about trig ratios. Sohcahtoa is the sine of theta. S is equal to opposite side over the hypotenuse. And so if I label A theta, this is my opposite side. This is my adjacent side because it's next to. My longest side is my hypotenuse, and I'm going to use those abbreviations from now on. And so my cosine of theta is going to be adjacent over hypotenuse. So I'd take, B over C, whatever those numbers happen to be. And my tangent of theta is going to be opposite over adjacent. So again, opposite over adjacent, whatever those numbers happen to be. And so then we transition into the 6 trig functions. Well, if sine of theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. I'm rewriting these, so you should understand the importance of copying them down because I know I'm going to need these. And if tangent of theta is opposite over adjacent, that's only 3. The other 3 look like this. Sine is paired up with cosecant of theta, and cosecant is the reciprocal. So it's going to be hypotenuse over opposite. They're paired together because you just flip that. Cosine is paired with secant of theta is hypotenuse over adjacent. And tangent is paired with cotangent to be adjacent over opposite. So what does this look like? What we're finding is not just opposite over adjacent, it's actually numbers or letters or variables, whatever it happens to be. And so if I'm finding the indicated trig functions for the triangle ABC, what is the sine of A? Well, if I'm looking at A, sine would be opposite, so S-O-H, sine is opposite over hypotenuse, so the sine of A would be the opposite side, A over hypotenuse, C. The cosine of A would be adjacent over hypotenuse, and the tangent of A is going to be the opposite over the adjacent, or A over B. In this case, now I'm going to take angle B, and I'm going to switch colors here. I'm looking at B now. The sine of B is opposite over hypotenuse, so B over C. The cosine of B is adjacent over hypotenuse, or A over C, and the tangent of B is opposite over adjacent, or B over A. It's not a coincidence that you see some of related values. So the cosine of B and the sine of A are related, they're the same thing, and the cosine of A and the sine of B. There's something called the cofunction theorem that we're going to talk about later. It talks about how all of these angles are related, okay? Something of note that we need to remember back to geometry is these special right triangles. And as we do this, these are going to lend us help when we're talking about the unit circle in the next couple of sections. And so as we look at this, understand, special right triangles have 2 acute angles, okay? 16 and 30, 45 and a 45. So we can take the trig ratios and find them. And the beauty of it is, in the unit circle, it's just the reduced values. And so if you can remember that, in a 45, 45, 90 degree right triangle, the 2 legs are the same, they're x, and the hypotenuse is x times root 2. And in a 30, 60, 90, the shortest side is opposite 30, the hypotenuse is twice that, and the other leg is the root 3 times that short leg. you can do all of this from memory. So as we set up these ratios, there's a bunch of them, but as we go through them, you're going to see there's a pattern here. So the sine of 45. So I'm just going to, for example, take this one as my theta. So the sine of 45 is x over x root 2. Well, if it's x over x root 2, that really is 1 over root 2. If I rationalized, that would be the square root of 2 over 2. Okay? Well, the cosine of 45, look at what happens. Adjacent over hypotenuse, it's the same values. So this one's root 2 over 2 also. The tangent of 45 is going to be the opposite over the adjacent, so x over x, which is equal to 1. Well, look at this. Just take a look. As we talked about before, it's the reciprocal. So really, if I could find 3, I just need to find the other 3 by doing the reciprocals. So the secant goes with the cosine, and so, oh wait, in a 45, 45, 90, they're the same. And so what's it going to be? So in this case, it's going to be 2 over root 2. Well, look at what happens. Now I got to rationalize again. I could have gone back to the original. But if I rationalize again, look at what happens. 2 root 2 over 2. So it's just root 2. The cosecant of 45 is the same thing because they're going to be the same. And the tangent is x over x, or 1. So here's my answers. Root 2 over 2. Root 2 over 2, 1. Root 2, root 2, 1. That 45, 45, 90 is easy because 2 of the sides are the same. Let's take a look at 30, 60, 90. 30, 60, 90, the sine of 30. So in this case, I'm looking at this one. So the sine of 30 is opposite over hypotenuse. Well, that's x over x, x over 2x, which would be 1/2. The cosine is adjacent over hypotenuse. So x root 3 over 2x. D's cancel. It's going to be the square root of 3 over 2. Tangent of 30, opposite over adjacent. And if you want to pause this and try these and then come back and see if you got them right, you can. Opposite over adjacent. So let's see. X over x root 3 would be 1 over root 3. If I rationalize, okay, there we go. Let's keep rolling. Secant, once again, it's the reciprocal of cosine. And so it's going to be 2 over square root 3. So if I rationalize it, 2 root 3 over 3. Cosecant, I'm just going to flip over sine. It's going to be 2. Cotangent, I'm flipping over tangent, so it's 3 over root 3. Again, I can rationalize this. 3 root 3 over 3, so it's just root 3. Here are my answers. 1/2. Root 3 over 2. Square root 3 over 3. 2 root 3 over 3. 3 root 3 over 3, which reduces to just root 3. Guys, this is why trig is so straightforward. I think we all get freaked out about it, but don't. It's matching up and knowing these ratios and just pairing them up to what they're supposed to be. Sine of 60. Let's use pink. Sine of 60, opposite over hypotenuse, x root 3 over 2x. X is canceled, equals root 3 over 2. Hello, where have we seen that one before? Oh yeah, it's the cosine of 30. They go together. And so the cosine of 60 is going to go with the sine of 30. That's going to be 1/2. The tangent of 60 is opposite over adjacent is just square root of 3. Now, the other 3 are just the reciprocals. So the secant of 60 goes with cosine. It's going to be 2. The cosecant goes with sine. It's 2 over root 3. Rationalize. 2 root 3 over 3. Cotangent of 60 is the flip of the tangent of 60, so it's going to be 1 over root 3. And I'll rationalize. And we're circling. Square root of 3 over 2, 1/2. Root 3, 2, 2 root 3 over 3, and square root of 3 over 3. Why am I rolling through this? It's a review, so you've done it before. And if you haven't done it before, it's based on something I know you've done before. And as you do it, what you're doing is you're just matching. And so if you have questions about this, please ask me. But really, it should be just a matching game. So what are they going to ask us to do? They're going to ask us to do a couple of things. They're going to ask us to fill in the 6 trig values for triangles. As we do that, they're going to leave out certain pieces of information. And that's okay, because when they do that, they're asking us to take the next step. And so this is the extension. They're not giving us all 3 sides, or they're not giving us all of the angles, but they're asking us to find them. Given the right triangle ABC, such that sine of theta is 5/6, and that didn't really print that well, but this is 5/6. And because it's 5/6, we want to evaluate the other 5 trig functions. What does that mean? I got 6. I know this one is 5/6. Give exact answers. Well, what's the problem? When I go to, well, first of all, let's fill it in. The cosine means opposite over hypotenuse, so this is 5 and this is 6. When I go to fill in cosine, I'm going to adjacent over hypotenuse. So this is A over 6. Well, what's A? We don't know. How are we going to find A? Right triangle. No 2 of the sides. Oh yes, Pythagorean theorem. So we're going to use Pythagorean theorem. To find the third side. So here we go. It's not a coincidence. A squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Just to review. And so what's my leg? My leg is a, which I don't know, plus b squared, oh yeah, that's 5, equals c squared, oh yeah, that's 6 squared. A squared plus 25 equals 36. And I'm just going to solve for a. A squared equals 11, so a is equal to square root of 11. Why not plus or minus? Well, it's a length of a side, so I'm not going to have a negative in this case. Okay, that being said, this now gives me everything I need, because I know that my cosine, a over 6, is now root 11 over 6. And I'm just going to fill in my diagram, root 11. So the tangent is opposite over adjacent, so 5 over root 11. If I rationalize, that looks like root h. Come on. 5 over root 11. Rationalize. 5 root 11 over 11. How do I find the other ones? Conveniently, I paired them one next to one another, or I paired them right next to one another so that you could just go like this. Reciprocal. Reciprocal. Did it again. But I need to rationalize. Keep doing it. Looks like root pi. I don't want that. So this is 6 root 11 over 11. Cotangent, really what I'm going to do is I'm going to take and go back to this, because it's really 5 root 11 over 11 is a rationalized version, so it's equal to the original. And so really I can just take this and just flip this over. So I can say this is root 11 over 5. Okay? That's my 6 ratios. So what did I do? Use Pythagorean theorem to find the third side and then filled in my ratios from there. All right? Go ahead and try the next one. We'll talk about it in class if you have any questions. And thanks for watching. We'll see you next time.